never remember to ask what time we have to leave, so. It's what? Oh, Celsius.
Welcome, everybody. It's my special pleasure to welcome Paweł here at the presentation. Paweł is has graduated from our university, so it's quite appreciated to me. And Paweł will say about talent and short gap. So I'm sure that if Paweł will say about Poland, about USA, or maybe globally, because actually Paweł moved from Poland to USA, increasing the gap in our industry. No.
Right, thank you for the introduction. Good morning to you, and thank you for staying for the last day and the last keynote, I believe. I appreciate it. Hopefully I won't disappoint you. Hopefully you'll find it interesting. Okay. Well, it's a special honor for me to be here as a keynote speaker. 18 years ago, I started, like many of you, with a name tag that said "Ask Me." So I was on the organizing committee for this conference for a long, long time, and it's an honor to be here as a keynote speaker. As I said, I'm glad to be back as well. So this morning, I would like to talk about the analytics talent shortage and gap. Two different things. I'll explain. Between business schools and industry needs in the United States, so not globally and not about Poland or Europe, okay? So let's take a look at the outline. We'll start off by trying to define analytics. It's not easy, but at least for the purpose of this talk, we'll try to do that. And big data analytics as well. And then we'll talk about the industry needs in the United States. Then we will cover the talent gap and shortage of talent. Again, two different things. And in the end, I'll talk about the academic programs, curricula, and graduates in the United States, and I'll use my own department and the programs we offer as an example of business school's response to the problem. So let's start with the joke. Okay, so this is from my favorite cartoon. What it says is the boss tells the analyst, use the CRS database to size the market. The analyst responds, that data is wrong. Then use the SIP database. That data is also wrong. Can you average them? And he goes, sure, I can multiply them too. I just hope this is not the state of the art of the discipline of analytics. Maybe in some companies it's true, but hopefully it's not true everywhere. All right, so let's go. Analytics and big data analytics. I used Informs Analytics as a source here for these definitions, and the emphasis is mine. So there are two definitions that Informs Analytics. Informs is a large global organization of information systems, operations, research, and management science. And well, it's based in the United States, but it's a global organization. And they define analytics as a complete business problem solving and decision making process, or a broad set of analytical methodologies that enable the creation of business value. So I emphasize business because I think it's pretty clear that the discipline of analytics, as we know it now, belongs to business schools. And if so, how will we prepare our graduates to enter that market? Not so well. But let's try to continue on with the categories of analytics. And I'm sure you've heard many different categories, about many different categories, or you've read many different taxonomies. But this one is also from Informs. I like it because it's simple. And it fits pretty much everything quite well. So they divide analytics into three areas: descriptive, predictive, and prescriptive. And without reading the definitions, I can tell you that descriptive pretty much means reporting, all kinds of reporting. Predictive is forecasting, and prescriptive is OR. So that's the shortest way of explaining what they are. But I'm sure many of you can say, wait a minute, there's so many different categories. Okay, here you go. How about unstructured content analytics, text analytics, web analytics, workforce analytics, social analytics, and so on and so forth. And you even have some vendor-specific names like Watson Analytics from IBM, Hyper Performance Analytics from SAS. Is anything missing here? The big data analytics? Right? Okay. It's right here. I don't have a presenter's view, so I don't know what's on my next slide, but I'll try. Okay, so the big data analytics, the current definition is basically in terms of Gartner's 3 V's, volume, velocity, and variety. We all know that this is a conference on big data analytics. But I may say something radical, but I don't really need that definition for what I'm trying to talk about, because it seems to me that it's just one of the types that can be classified under these 3 major categories. And some of the publications that pertain to the market analysis and the business school's response to the need for analysts, they do the same thing. They say, okay, big data is just one of the categories, and we don't really need to get into the details of that. Nevertheless, I believe that big data is about new technologies for storage, processing, reporting, and visualization, but it's also a new way of thinking, and it provides a new way of reference. So it's something bigger than just another technology. I had to say that, because it's a big data conference. Anyways, this is the market, and these are the top analytics vendors, general analytics, all aspects of it. In 2015, SAP had 10% of about that $12 billion market. SAS Institute had 9, IBM 8, Oracle 7, Microsoft 5, and then there are others. What's interesting in this chart, and this is from apps around the world, I think that the big chunk of other, 42%, so that indicates quite a significant level of fragmentation of this market, despite the recent trends that we observe. One company, especially IBM, is buying all these small companies, but still, it appears to me there are many more companies to buy. So this is analytics in general, okay? Let's take a look at the Advanced and Predictive Analytics, or APA. Do not confuse with American Pale Ale. APA software, Advanced and Predictive Analytics. I know this is 2013. I was looking for an update of this study from Predictive Analytics, but I couldn't find it. But I'm pretty sure that the numbers are similar. What's important here, there are 3 major players in Advanced and Predictive Analytics. The reason why I singled out this specific area is it seems to me, based on my experience as a consultant and also as my experience as an academic, that predictive analytics is the one in high demand by businesses these days. Advanced and predictive analytics. So I'll be making this case throughout my presentation, so this is why I selected that. So 3 major players, and SAS Institute is the biggest chunk of that market. And there are others, and there's also open source systems or environments, which many of you are familiar with. In particular, the R environment, which is these days, I think, a must. If you want to call yourself an analyst and you don't know R very well, you may not get a job anymore. To the point that companies like IBM embedded a node in their SPSS system which says R. So basically, you don't really need to know SPSS. You can write everything in R and plug it in there. So that is an interesting phenomenon in which this open source environment is so ubiquitous in the field that everybody's talking about we have to introduce our courses, we have to train our graduates, future employees in the sector in art. All right, so that's the introduction to analytics. So I hope that we now know what we're going to talk about. And now let's talk about what the industry in the United States, they say they need. This is from IBM. They define two different positions in the field of analytics and big data analytics. But they make a distinction, and I think very rightly so, between the data scientist position and the business analyst position. As I was preparing for this presentation, I noticed that these two terms or positions are used interchangeably, and many different statistics are provided for one of them or both of them, and they don't make a distinction. I think there is a distinction, and later I'll show you why. But the definitions are pretty simple. The data scientist combines the skills needed to collect, store, manage, and understand patterns and trends in data. It doesn't tell you much. Like data mining, that will fit here quite well, right? But it doesn't tell you much. But according to IBM, the business analyst applies business intelligence and other techniques to turn information into business insights to decisions, and decisions to implementations or applications. Interesting. But what exactly does the data scientist do? And how is it different from what the business analysts do? It seems to us from these definitions that data scientists are more specialized. They go more in depth as opposed to business analysts, which is apply the available technology to provide the information that is needed to make better decisions. Let's take a look at the industry needs. We'll explain that a little bit more in just a minute, but let's talk about the industry needs in the United States. I looked at the 2015 Wanted Analytics, and they tracked about 200,000 positions with the big data keyword in them, okay? So it's all about analytics, but big data is there. What's interesting is the median advertised salary plus benefits was $124,000. For comparison, the median personal income in the United States is about $41,500. Now the family household income is $57,000, but this is personal income. Does anybody know what it is in Poland, the median? I actually checked because I was curious. $8,500 per year, the median income, personal income. Okay, so what was also interesting in this particular study was that the parent company of Dell posted 1/4 of all these available positions, so 51,000 positions were advertised by the parent company of Dell, one of the Dell companies, right? And IBM, Cisco, put together had about 13% of all available positions, and this is from Wanted Analytics. So now we see there are many jobs posting, and we know what the median salary in this particular field is. It's a little higher than the other fields. Okay, the top 5 industries which express the needs for analytics are professional services, scientific, technical services. 30% of all the advertised positions were in these industries. Information technologies, 19%, manufacturing, 18%, finance and insurance, only 10%. That came as a surprise to me. I thought they'd do a little bit more. But analytics and retail and trade, 8%. The IDC in 2015, so not too long ago, predicted that by 2018, the U.S. will need 100,000, almost 200,000 people with deep analytical skills. Deep analytical skills, but I'll show you in a moment another study which contradicts that a little bit and says that you will only need about 50,000 people with deep analytical skills, and there will be many more jobs for people who just have analytical skills. So next year, which is 2018, the actual numbers are that the number of positions will exceed 490,000. But these are all positions that have anything to do with analytics. These are not the analysts or the data scientist positions. But there will be less than 200,000 people in the States to fill these positions. And they take into account attrition, immigration, everything. So that doesn't sound too good for the industry. Are there any ways of remedying that problem? We'll talk about that. Another thing is that this job, data scientist and business analyst, is very popular among those who seek employment in the field. The Glassdoor's annual survey, and this was, I think, this year, 2017, they analyzed the jobs according to 3 dimensions: median salary, number of openings, and the job satisfaction. The last one is measured by a survey. And the data scientist is at the top the second year in a row. And this median salary is close to the other study, 110. So it's very popular. So why we don't have enough people to fill in these positions? And this is a study from the PwC, PricewaterhouseCoopers, and this is a 5-year forecast which was created back in 2015. And this is the one that I was talking about when they distinguish clearly between the business analyst and the data scientist position. The data scientist is being more specialized, more in-depth. They think that there will be less open positions, fewer rather, open positions, but the growth will be higher than in the case of the business analyst position. Most of the positions in analytics will be in the business analyst field, and they're expecting more than 300,000. And the growth, but not as high as the growth for the data scientists. So they clearly make a distinction. We'll need fewer experts in analytics, and we'll need a lot of people who understand how to apply the tools and turn data into information into insights into decisions, and decisions into actions. And there's another chart. This is, I think, interesting because it shows the difference between the data scientist and the business analyst positions from the employer's perspective. Okay? The level of education that U.S. employers want or expect from the analyst, and the level of education that the U.S. employers want or expect from the advanced analysts or data scientists. As you can see in the second bar, over 40% of those who will be hired as data scientists will have advanced degrees, at least according to the employers, masters, PhDs. So this is a niche, and I'm giving you a hint of what's coming, where my department, my school, is trying to explore. All right. So now let's talk about these two different issues of the talent gap versus the shortage of talent. So the shortage is obviously we don't have enough people to fill in all the available positions. But what's the talent gap? Talent gap is that we train people for some other positions, not for the analyst positions. We don't give them the skills that they need to get these jobs. And that's a major problem. And when I say we, I mean business schools. And as I made my point at the beginning, the discipline belongs to business schools. So it's our responsibility to build programs, revise our programs, to provide a steady supply of people who can fill in these positions, because that appears to be a need. So in terms of the student supply, 23% of educators say that their graduates will have data science and analytics skills. 23%. But the employers say that 69% of the employers say that they will prefer job candidates with these skills over ones without. So that's a problem. We, the educators, we're not listening. We're not doing a good job. That's the gap. Another study, 2017, Business Roundtable, skills that are tough to find on the job market. Number one is cybersecurity, 97, but that doesn't belong to the business. That, in most cases, it belongs to the computer science department and an engineering school in the United States. Second, data science and analytics. 95% of employers surveyed said that they believe that these are going to be the skills. Hard to find. Interestingly, critical thinking and problem solving comes next. Design systems thinking is number 4. Innovation, creativity type. You see a problem here? Those are skills which are based on systemic thinking, logical thinking, mathematical analysis. Now let's take a look at a few past predictions, because predictions are very difficult to make, especially about the future. But when we look at the past prediction and compare with what we have now, we can determine whether or not these predictions were accurate. This is an interesting one from the IBM's Director of Global University Programs. He said in 2012, he wrote in 2012, when big new technology waves come along, as we've seen in the last 5 years, with big data analytics, that's in 2012. He says it takes about 10 years to train the next generation on the new skills that are needed. Well, if the 10-year pattern holds, the big data analytics, a new wave of graduates should be starting to emerge next year. But will they? Highly unlikely. And I'll give you some thoughts about what I think the reasons for the problem are. Again, the past prediction from 2011 study by McKinsey, they predicted that the talent, not the talent, but that's a shortage, talent gap, they actually predicted the shortage, they call it a talent gap. The shortage, or the difference between the demand and the supply, will be 50 to 60% by 2018, and it appears to be the case. And they took into account many different things, the supply of graduates with deep analytical skills and the job postings. So let me try to share with you some thoughts, my thoughts about the possible reasons for talent gap, based on my experience again in academia and based on my experience as a business consultant in analytics. I think the analyst's job, in particular the data scientist's job, requires multiple types of skills, and not just scratching the surface of these skill sets, but really an in-depth understanding. So then we have the data analysis skills, in-short statistics, so black box models, white box models, being able to transform the data from the raw format to something that you can run through your models, being able to use the tools such as R or any other for predictive analytics. Not too many people have these skills, and they're not easy to learn. It's just like with sports. If you start too late, it's over. Right? You have to start them early. We don't. In the United States, we don't. We make the programs, high school programs, easier and easier in terms of the hard skills, and the university follows through. The mathematics that we taught 15 years ago is not the same we teach this year. And then there's data management skills, being able to find the sources of information within the organization, outside of the organization, extract, transform, and load, extract, load, and transform if you're in the big data field, right? And then be able to process that information to get decisions and insights and apply. And the third one is the mainstream business skills. Some of you could argue that, at the highest level, the analytics is the same for any industry, whether you do automotive or you do, medical or you do education, doesn't matter. Same models, statistical models. Yes, but that's not what the industry wants from the graduate. The graduate from a analytics program is supposed to be versatile, supposed to be very well versed in data analysis skills, data management skills, and general mainstream business skills. So they can solve problems and provide answers. And we don't do it well. We don't train them well. The industry tells us you're not doing a good job. It's hard to find people who are willing to do all these three things and do them well. That's at least our problem. To provide additional evidence to my thoughts about it, this is from the Inform Certified Analytics Professional Program. It's a program that they have recently introduced, similar to the Certified Project Manager. You have to be in the industry for 5 years to even attempt that examination. 5 years experience is required. So it's not something you can take fresh out of the business school. It's a difficult test. You look at the sample questions, they're not easy. And more importantly, this certification combines all these different areas. And the approximate weights are provided on the website so you can see that pretty much all except for the model lifecycle management, which is mostly the domain of general managers, everything else is approximately equally weighted. So you have to be really good at framing, at stating the problem in terms of analytics, data management, methodology, selecting the right tool for the job, build a model, deploy the model, so you have to be able to implement it in order to be a certified analytics professional. And it requires 5 years of experience in the field. So where's the 10 years that it takes to train these graduates when a new big wave of technology comes? Might be difficult. Might be more than 10, which may create feedback that will basically quench the flame of analytics that is burning quite high, quite big right now. So let's take a look at academic programs. I just have a couple of slides here because the hard part of the work was performed or done by two of my colleagues from my department, Dr. Terrell and Kapoor. Dr. Kapoor is chair of our department. This is from the paper that they have recently, I think in 2016, published in the Communication of the Association of Information Systems. The paper was about a study. It was a study of the business analytics and data science programs. They studied the maturity of the programs at 100 top-ranked business schools, and they compared these programs to 20 unranked business schools. And there are multiple findings. Some of them were that the data science programs are more narrowly focused and rely on computer science, so they take courses outside of business schools, and so math, engineering, and business analytics programs focused on solving business problems, and in most cases they were entirely contained within business schools. Also, business schools in the US, according to that study, largely they did not reach acceptable levels of maturity, and they used an established maturity scale, whatever they use in this field, and they proved that we're not there yet, and it's been a while. Again, we're looking at 104 top schools in the United States. We're not there yet. Not to even mention the 20 unranked schools, right? So they noticed also, they found out that the top business schools tend to incorporate more business analytics courses than the lower ranked schools, especially into their graduate programs. And they had all types of numbers to show. But this is not from their study, this is mine. I just wanted to give you a perspective. We, in the United States, graduate almost 2 million students each year, in all fields, okay? But out of all these fields, I selected 3 which might potentially feed the market, the industry needs, into the industry needs. So business, obviously, computer science and information systems, and mathematics and statistics. Now, can you see the mathematics and statistics? This is just, the numbers are very small, so not too many students choose that. For obvious reasons, it's difficult, right? So you may say, wow, business, 363,000, indeed. This is a lot. It's, I think, the biggest chunk, single chunk. But if you take a look at the details, you will notice that nearly half of them, if not more, they just choose business administration and management. It has nothing to do with analytics. Or they can just read analytical reports. Accounting, economics, finance, turns out that the majority of business graduates do not have the skills which are needed by the market. So we're not addressing the shortage, we're not addressing the gap, as of now. So let me show you the last part of my presentation, in which I will use my own department as an example of a school that tries to respond to the market needs, at least in terms of closing or bridging the gap between the industry needs and the supply of graduates. But I don't think we'll have a major impact on the shortage. That's a different global problem. So our department, the Information Systems and Decision Sciences department, in the Mahalo College of Business and Economics at Cal State Fullerton, the only university in the world, they say, where you can ski and surf in the same day. It's a lie, because of the traffic. So if you could do it at 2 a.m., maybe, but it's the traffic that makes it impossible. But that's how we advertise, by the way, so we get students, right? But we have 25 full-time faculty members and 16 part-time faculty members who specialize in information systems, business analytics or business statistics, and decision sciences, which is operations research and operations management. And I'm very proud to be one of them. We have another one, my wife, who is also part of the faculty. Based on the AIS rankings, in I think it was 2015, we as a department ranked as number 4 in California. In IS research published in top journals, Basket, 32 ranked business schools in California. So we were actively involved in research. And I would like to talk about our graduate programs. We have a very large undergraduate program. I think we're one, if not the largest business school. I think we're second largest business school with 9,000 plus students. But let's talk about the graduate classes, because this is where we think we are closing and bridging the gap. So our graduate classes are taught by professors who stay current with the latest development. Nearly, I think, about 40% of our faculty are actively involved in consulting in their respective fields, myself included. And they're also very actively involved in research. So that's important, because not all programs have that requirement that if you teach graduate, you have to be included in the graduate faculty. So that gives us an advantage. Also, our Masters of Science and Information Systems program holds the accreditation from an accrediting body, ASCSB, and we meet all those standards. We have been doing this for years. So we are a ranked school, or accredited ranked school. Now, 10 years ago, we started a program which is not yet accredited, but it will be, which was a fully online Masters of Science and Information Technology, which was geared toward people who work full-time in companies like Boeing or Raytheon, which we have in the area, and they don't really have the time to come to the campus and listen to lectures. They just want to be able to work at nights at home and get their degrees, their master's degrees. Now, this program turned out to be a major success. We were ranked #1 in California, #6 nationally for the fully online graduate programs in IT. And a few years ago, we started the process of extending this program. We only have one cohort, only 30 students, high quality, selected from 100 plus or hundreds that apply. But we started the Master of Science in Data Science, which is a spin-off, and it targets specifically those who want to get a job as a data scientist. It went through all the approvals and will be launched next year. How do we think we can bridge that gap? What gives us that competitive advantage over other schools? Well, we are a department of information systems, and we have people in management information systems who do research and teach in this area, have doctorates in management information systems, and they consult in management information systems. We have people in operations research, same thing, and also with business statisticians. These are the three circles, right, that I showed you, the three areas, the three disciplines, and all of them are involved in the program. All of the faculty must be graduate faculty, so must be academically qualified or professionally qualified as defined by the standards, by the accrediting body standards. And we also have something that I think this is the best source of information for us, and this is how we made the MSIT program very successful. We have a business advisory council, mostly C-suite executives, with whom we meet twice a year over lunch, and we listen. We present what we have, and we listen to what they think the needs are going to be, locally, globally, how we should prepare our graduates there. So we came up with an idea of an adaptive curriculum. I don't think that anybody here is a stranger to the administration being a big black object that it's impossible to move or walk around. And so every time you make the slightest change in your syllabus or the course description or the course title, it takes forever because it goes through 50 committees, right? So we have figured out many years ago, and we write our syllabi and curricula and course descriptions in such a way that they're based on the concept, not on the new buzzword. This way, we really don't have to change a thing in the descriptions, but we can choose the right tool, the new buzzword tool, or concept or technology to illustrate the concept we teach. That gave us an advantage over all these other programs that had to go through all these steps. We have very serious partnerships with major players on the business analytics market, especially with IBM, SAS, and Microsoft and Tableau, which means that they come to the campus, and you have trainings that normally cost $5,000–6,000. They offer it for free to our faculty, and we also manage to squeeze our graduate students in that. They wouldn't offer that to undergrads, but graduate students are fine. So we are familiar with the tools. Our students get training and certification for free. We also have the Center for Information Technology and Business Analytics. They organize all these trainings and partnerships, and we have a very active student club called Business and Data Analytics Club. So there's so much going on in terms of analytics that I hope it will be a major success. And so far, even though we did not have a graduate program that specifically said, Masters of Science in Data Science or in Analytics, we've been able to place our graduates in these companies recently. And some of them we're very well familiar with, right? Our graduates for IBM, for Suzuki, for Toyota, for Yahoo, for Intel. So this is our success criteria. Not the GPA, not the graduation rate, but we proposed a long time ago to measure the success of the program by our graduates. I mean, it's not enough measure in a strict sense, but you can measure the salaries, the promotions, but the perception and the perception of the employers and those who got these jobs is extremely important qualitative measure of what we do. Okay, so what is next for the analytics job market? What I think is next. Wait and see. And after I talked about all that, you might say, what? Yeah, I say wait and see because, many firms, they report investments, large, huge investments in business analytics, but I have seen very few reports on substantial returns. Now we have the shortage and a talent gap. What may happen is it may die down like other big waves of technology innovations, just because of the shortage and gap. So I think that the talent gap and shortage, I personally think, will be addressed in the short run by immigration. There is a category of highly skilled professional worker, and I think they will take some to address the immediate need. That's what I think. But I don't think it's going to help in the long run because there's just too many that we'll have to import. And then half of the world can keep up with the demand. So something is going to have to change. In the academia, I think there will be more emphasis on the deep skills as opposed to just being able to use technology that is available. And I think this is going to happen in the graduate programs for obvious reasons. This is where the demand for data scientists is that the employers want most of them or many of them with graduate degrees. What is next in terms of technology? I think there's more and more going on with unstructured and so-called dark data analytics. So text, audio, image, video, we're not doing a good job in that. And there will be more big data from the Internet of Things. And I also would think I'll give them a chance. The cognitive analytics, although I have to say I hope there's nobody from IBM here. I was very disappointed by the Watson Analytics program. I know Watson is used in some other fields with some success, especially medical research. No?
Not with success.
Okay, so I can't say anything about it. I haven't tried, but I tried to like Watson Analytics or use it even in training. Unfortunately, I didn't find any good applications of it. Finish with a joke. All right. So this says, I didn't have any accurate numbers, so I just made up this one. Studies have shown that accurate numbers aren't any more useful than the ones you make up. And the question is, how many studies show that? 87. If you have questions about the numbers, that's how you answer it. Thank you very much for your attention. I'll be happy to take questions. I hope I know the answers to them.
Okay, so thank you for the excellent presentation, especially for making clear the distinction and also making an overview of the whole situation. Any other questions? Comments?
Yes.
Of course, I'm a little bit curious because what is said on the last slide, maybe imply that your opinion about the education is that it is not as good as in other countries. Of course, if you can fill the gap by people from other countries, then obviously the education in these other countries must be better than in your own country.
Not necessarily. It's a shortage also, so we don't have enough, right? So
Yeah, of course, but if you can get well-educated people from other countries, then obviously these other countries must be better than your
I
own.
don't think it's the right conclusion. What I'm saying is if you don't have enough to fill in your country, there are good people in other countries who may not be able to find employment. So the United States has a history of inviting them over when there is a shortage. Simple. So
124,000 versus 8,500. Easy choice.
oh, there you go. Thank you, Dr. Yeah. So there's
So what was the remark? 124,000 versus 8,500. Your choice.
yeah, the salary, right? So that's also another aspect. But that's it's not the only conclusion. I don't think it leads to that conclusion because we do have these people. It's just not enough. That's the problem, right? Okay. Very good. What else? One question? Yes, I must have covered everything.
So maybe one remark. So the shortage is visible everywhere, also in Europe, of course, we notice that. And my university, together with another university in the neighborhood, the university, tries to address that. So we started 5 programs on data science, 2 undergraduate and 3 graduate programs. And if I look at the type of students that go to these programs, so we are running the 2nd year now, these are very talented people, hardworking, strong skills, and so on. But somehow the mindset that I notice with the whole population is that they want to analyze a business problem, solve it quickly, get the data, apply some kind of method, find some kind of answer. But the depth of analysis I'm missing. So at the moment I find we are not doing a good job there, because they come with another, and then once you start kind of scratching the surface, there are all kinds of issues with data analysis and so on. So this deep skills that you are saying, I think it's very important to give them indeed, but I think it's also a challenge for the academia to teach them properly to this group. So that is something we'll have to work on. I think.
Absolutely, it starts with us revising the programs. I don't think that we can just start, hoping that these people will flock and they will train themselves. So that's one of the important issues. Thank you for bringing it up. Yeah, I didn't realize the problem is so prominent in Europe as well. I just heard before the presentation. Yeah.
Okay, this involves politics as well.
Oh, nice.
We've been trying to move more analytics throughout the curriculum. But you get to a certain point, and some other department has to agree to sacrifice their material in order to incorporate more of the big data or just analytics in general. How have you been successful at overcoming this hurdle? Is it just through the introduction of an entirely new curriculum with a new degree, or have you been able to get it into the degrees for all of the business students?
That's a very good point, Gary. Thank you for this question. And the honest answer to it is by the adaptive curricula that I meant. Is they're written in such a way that nobody in the finance department or the marketing department really knows that this is kind of out their field. But it's not the way. It is the new curricula, or the new entire program that we propose in order to show the university and all the committees that what we are offering is the whole package. And from the political standpoint, politics within the university, we have courses which are team taught by marketing, finance, or accounting faculty, and that way they get to agree that if they have a share in this program, then. So we have a couple of courses which are team taught or taught by other departments. Does that answer the question?
Hardly.
Anything else? Yes.
When you get in first years of graduate students, we have a problem in Kazakhstan where the quality of the graduates of high school, unfortunately, is deteriorating. So, what do you do to match up the entry level to the level where you can, or at least begin teaching them something? Because it's a huge problem in the country where I'm from.
Thank you, Victoria. This is an excellent question, and I noticed that many heads went there. Even in the United States, we have the same perception, same problem. And we're now talking about the undergraduate programs. I didn't touch upon them, but I'll be happy to expand. We have experienced the same issue. We have lower and lower quality people, even though our standards, our admission standards haven't changed. So it's amazing. So they still have high GPAs and they still get a passing grade in their calculus classes and everything. And we noticed that there's a mismatch, that many of these students flock to the area of analytics. I'm talking about undergraduate right now. They choose the major that requires forecasting, requires operations research, that requires data warehousing, data mining, everything, and they escape after the first semester because this is not what they wanted to sign up for. Okay. So we noticed that, and what we introduced is it's more work for the faculty, okay? But there are mandatory meetings with would-be analysts. So I have a group of students who choose me. I have to assign some time, and I meet with them and I talk with them. And during these mandatory meetings, I don't know what my colleagues talk about, but I ask 2 questions. Number 1, how are your math skills? Did you struggle with mathematics, or you're okay with it? So if they say, oh no, that's not my thing, mathematics is not my thing, then my second question follow-up is, what are you doing with it? Okay, if you struggled with mathematics, if you don't understand the basic things, that it's not for you. You're not going to pass statistics too. You're not going to pass forecasting models and everything. So we do it through advising. It's not an official advising. We have advisors who tell them which specific path to choose to graduate from a certain program. It's an unofficial advising, extra time, no extra pay though. But it's very effective because we, in a sense, I don't want to use that word with my sons, we scare away people, but we are doing them a service, I think, because they realize there's much more in the discipline of analytics that they can possibly handle. So that's what we do, advising, extra advising at the undergraduate level.
I'm curious, can you give a quick overview of the demographics of the
Cosmopolitan?
Yeah.
Okay, our demographics reflect the area. So we have 30-30-30 in a nutshell. 30% white, 30% Hispanics, and 30% Asian. There's obviously.
And what about age of the generation?
Oh, working young people are out of this high school, commuting and working. Many of them working full time.
Mm-hmm.
So it's pretty much similar to what else.
Yeah, I guess I was curious about, we read so much about the millennial generation.
Undergrad.
Right.
Undergrad.
Right. Right. And we read so much about that, and how obviously, each generation kind of thinks differently, has different expectations, et cetera, how they want to live their lives, their lifestyle versus work, and so forth and so on. And I think that your advising, it sounds to me like a really important step in this whole process. But I was wondering if you saw any differences in terms of if you kind of chunk that profile out of people who come to you. Do you see anything within the data on the demographics of the people who are applying that give you any insight into what piece of that market you can go after in a more sustained way that seem to bring to you the kind of prerequisites needed to take the next step? And obviously, from what you've said, then you follow people afterwards to see where they're placed, how do they do, et cetera. But you need the data at the beginning too.
Absolutely.
Yeah.
I can answer this question based on the anecdotal evidence, based on my 20 or 30 meetings, advisory meetings per year. I noticed that there's a group of students, every university has that group of students that you feel they don't belong to your school because they should be somewhere higher. Mm-hmm. These are people who are likely ended up in cosmopolitan for financial reasons or for proximity reasons. So this is my best target group, and those are my best success stories.
Yeah, sure.
And these people turn not only into very successful employees, and they move up in the ladders. I have a handful of these examples. But they also became friends, and they want to continue their education later on. After the 3 years, they want to come back and do something else in our program because they learned a lot from people like the people we have in our department. But if I had to tell you if there's a particular ethnic group or no, I don't think so. It's across the board. It's the motivation and the character and the passion for the discipline, rather than the worst answer that I get during these advising sessions is, I want to make a lot of money. So,
yeah.
The median salary is, so I just want to I want to make a 6-figure salary right out of school.
But that's kind of the.
Millennial approach.
Yeah, exactly.
So I said, okay, then let's talk databases, let's talk analytics. Do you know this? Do you know that? No, no. So it's not that. Probably, right? But there's no particular, it's not the older, there's even age-wise, there's military veterans. They're absolutely fantastic. So if I were to single out based on my anecdotal evidence, a single group that I think I would target is the veterans, because they have the character, they know they follow the rules, they know exactly what's expected of them, and they most often than not they succeed.
So if you feel good.
Yes.
So we're all competing for the same military veterans.
Yes.
Really interesting.
Thank you. Very good. Professor Bartoszewicz.
I have one question. As my opinion, the role of data analysis is a problem of discussion about the details of the company, about the finance of the company, logistics, and so on. But really, it's more about the technology. So the problem of bridging this assumption, because we are very good at technology, but it doesn't mean for management of the company.
Absolutely. I agree 100% with Professor Bartoszewicz in the three circles that I showed, right? He mentioned two of them, but there is also the statistics. We cannot teach statistics separate from technology and separate from business if we want to train future analysts. We used to be able to do it in these silos in the past, and we were hoping that they will somehow make these connections later when they get on the job. Employers these days, they want them to understand everything and being able to make these connections. They want them to be versatile. I had that word everywhere, versatile. They need to be able to juggle multiple skills at the same time, including interpersonal skills. So I think we need to rethink the way we train them completely. Very good point. Thank you. Oh, the boss has a question as well.
Okay. I would like to thank Paweł for this presentation. Unfortunately, I had to be by the faculty meeting, and I would like to use this opportunity as a point of tradition, because Paweł is a full professor. He was here at our department for not many years. He was a couple of years because he needed really a few months to write his PhD thesis. Unfortunately, the reviewers were a little bit slow. But it's next step in the tradition. During this meeting, Bartek, you know Bartek as a chair of organizing committee, and since today he became assistant professor at our university. As a very good message. And then the second point, you know Wodek because of taking photos and because of participants in 4 presentations during this conference. And we opened the process of PhD on our faculty. Congratulations. So, we have some precedents, and I think that is a very nice opportunity because we are exactly as usual at our department on time. There is time for lunch, but before we have also for Paweł this well-known books about the excellent use and detail